Good afternoon, everybody. I'm going to talk about challenges for utilities in a slightly different way from what Eleni introduced just a moment ago. So challenges in utilities go way beyond just drawing a few lines on a map. We have climate change, for example, on how we deal with natural disasters, and Brittany gave an excellent demonstration of that this morning. We also have energy transition challenges on the path to net zero, where we're trying to reduce emissions and the rise of renewable energy. And then we also have population pressures, which means we have to plan for future networks, probably a bit smarter, probably a bit faster than what we've done in the past. Plus, we also have social equity to deal with, and also social governance as well. All these challenges really require a digital transformation. And digital transformation requires new thinking about old systems in the following areas. Data quality. Our networks need to be a higher quality, higher fidelity, scalable, resilient. We need to distribute this data to our organisation, perhaps beyond, whether it be on a desktop, a web, or a mobile. Plus, we have to do it faster than we've done before, so we can all come together and make smarter decisions more quickly. We have to enable our people, self-enable them, either on the desktop or in the mobile space. And we have to be interoperable, of course, to work with other enterprise systems in IT and OT. That's operational technology, if nobody knew that before, which I did. Plus, utilities are also classed as critical infrastructure, so we have to do it securely, both in the way we store data and also the way we distribute data as well. Plus, we have to be innovative as well. We have to keep up with technology, introduce new techniques, maybe some of this AI that we've been hearing about, to improve our work processes. So what's the answer here? Probably no surprise to anybody in the room at this moment. ArcGIS. ArcGIS is an enterprise system. It gives you the tools for data management, mapping, visualization, analysis, and also discovery. Built on a modern network information model, ArcGIS has the solution for utilities in all those areas. But GIS can't do it all, of course, and so it has to be interoperable using modern APIs to link into the other enterprise systems that we have. SCADA, risk management, asset management, customer billing, and also engineering designs. Let's see where GIS is being used throughout utilities throughout the world. In the top left-hand corner here, we have outage maps in Nigeria and Florida. Outage maps are a great product to demonstrate the state of the network, keep our customers informed. In the lower left, we have examples from New Zealand. Vegetation clearing. Where's the vegetation going to be interrupting with our transmission lines? How do we clear it? How do we manage the contractors that are actually going to clear it for us? How do we use AI to determine where that vegetation is going to grow in the future, for example? We also see 3D for the position of transmission towers, whether that be geo-design or looking at the results after it's been built. And in the lower right-hand corner, we see the use of drones and LiDAR again for asset management or asset capture. And also ubiquitous is field mobility, of course, across utilities. GIS is used in just about every water and wastewater management or operations in the world. In addition to managing our network, we also see visualizations in water quality, water consumption, and leak management. And this is, again, where drones and the thermal imagery can come in for the actual leaks there. And on the right-hand side, again, we have our mobile use, but also, sadly, in a lot of parts of the world, in older networks, we still start to see lead contamination and other contaminants in the system. And again, GIS is proving a pivotal role to manage that and display that. Probably the utility that everybody forgets is telecommunications. But ironically, it's also one of the world's growing fastest ones because of the 5G technology. So in addition to managing fibre networks, we also see it for broadband placement, visualization of line of sight, radio propagation, for example, and also working out where we need the coverage in terms of are we having equal coverage for people on the ground in less serviced areas. So I talked about this new network information model, and in ArcGIS collectively we call that the utility network, which is basically a model plus the tools which allow us to edit it, visualize it, analyze it, for example. So I'm going to show you a quick demo of this. Let me start on the desktop. This is the city of Dubai in the United Arab Emirates. And Dubai is a pretty large city, so it needs a pretty good, reliable power supply and water supply. Let's take a look at their transmission network that we can see in the red lines here. Now, looking at lines on a map is fine, but there's another way to look at it, perhaps through what we call a network diagram or a schematic diagram. And this enables network engineers to actually see the actual logical layout of the network as compared to our spatial network. And the two views really work hand in hand. The map on the left, the logical network on the right. High voltage in this case is the grey lines, low voltage the yellow, and energy connects are the little red circles there. And you'll notice that any analysis that I do on one view can be propagated to the next. And that helps us when we're actually doing planning and analysis. So let's zoom in a bit to the network in general. So here we have a combined, this is an enormous power generation and desalination plant. Here we have 4 combined networks at work. We have the red power lines, we have blue water, green gas, and there's also a communications network here as well. So the utility network can work across multiple domains. So let's take a look at one of these generation stations. And let's examine one of these actual generators. We should see a large generator in here, and indeed we do. So this information could be coming from the GIS. In this case, it's coming from our asset management system. It's a very large gas turbine generator. We have stats on it, which have come from our asset management system. No real big surprise there. So let me zoom in again into the actual generation building itself. Now we begin to see the actual devices connected to each other. So we see the generator in blue, the fire suppression system in red. We see the gas coming in, the power coming out. Plus, we also start to see the communication system. And these are SCADA relays. And this is a wireless system, but still we're drawing relationships between those devices in the purple lines here. So GIS, in this case, is really helping us to see the things that other people can't see. There's a catchy phrase in there somewhere that Jack uses. So let's move on out of here. How can we enhance the visualization of this? So we're seeing lines in 2D. How about we see lines in 3D now? So let's have a look at the same generation building in 3D. So we can see that it's a multi-story building. I've brought in the generator and associated equipment from a CAD system, and we've got the 2D lines in situ as well. This is great for space planning if we want to put additional equipment in here, so we can just see actually if it's going to be put in safely and where it's going to fit inside that building. Now I'm going to jump over to some analysis. I'm going to do a small scenario here where we have a SCADA alert, and it said that a system has gone down, but we don't know what system it is. Normally SCADA would tell us, but just assume that it doesn't in this case. So an alert's going to be generated, and now what I'm going to do is do a trace from that SCADA system to find out what components it's actually connected to in this case. So this is simply a matter of doing a trace, in this case downstream. So we do the trace, and therefore it should select all the information that's connected to it. And no surprise, it is actually the generator and some other components. So what's happened here is the trace has actually gone across networks. So it's gone from the communications network to the electric network, and it's also happened in 3D because the utility network is a 3D system. And so sometimes looking at your data in 3D, as we've all seen today, is just an easier way to understanding the spatial relationships between our data. So the next step for Dubai would be obviously to report this perhaps, and a dashboard is a great way to do that. We have a live map, we have the incident report, we're bringing in relevant information from the different domains, and then we can all collectively put our heads together and work out what the solution here is. Let's take another example. This time I'll do it on the web. So this is a residential network, and we have some low voltage lines and transformers, etc. And the scenario here is that I've got an outage that somebody's reported. And so we'll go to that house and we'll see if there's anything crazy about it. This might be a smart meter which is actually reporting the actual live status of that meter, but in this case we can't see anything obvious. So what I'm going to do is trace up the network to perhaps the nearest transformer, because that's where the problem may actually lie. So I can simply do a trace. This is in the web this time, of course. Click on my house, set some parameters, and I'll do the trace, and it should stop at the nearest transformer, which is actually quite close. So again, I can do the same process. Let's have a look at this transformer, see if there's anything on this which tells us what's going on with it. It says it's in service, so the problem doesn't actually lie here, it lies further upstream. If I had multiple people reporting a problem, I could use those as well in this trace and isolate probably a different part of the network. So what I'm going to do here is trace up the network again from that transformer. It should actually stop at some sort of protection device or a switch, probably a fuse in this case. So again, we do the trace, and we can find out where that's actually gone. And it looks like a fuse in a fuse cabinet. So again, I can click on the fuse, see if there's anything interesting about that. Now, had I clicked on the right fuse, and I didn't during the demo, it would have told me that the fuse was actually out of service. So you can assume the fuse is out of service in this case, and so this is where the problem lies. So now what I need to do is trace the other way. I need to go back down the network, find all the customers that are affected by this outage. So just do the trace in reverse in this case. Fairly quick. Let me just zoom out to check my sanity to make sure it looks okay. It's quite a large residential area. And now let me look at the actual results and see what I've actually picked up during this trace. So it should be passing through every device on the network and downstream. So it's a couple of transformers, a couple of fuses, a couple of low voltage things, lights, etc. What I'm really interested in here is the low voltage service. And there's 62 people that are actually affected by this. So I can bring those people up, and then maybe get in touch with them and tell them they're going to have a bad day. So, whether you're managing generation, transmission, or distribution, adopting an enterprise GIS system for a utility can see significant improvement in operational efficiency, reduce costs, and help provide a better service for your customers. So if you're ready to adopt a GIS, then the technology is ready to support you. And as Eleni said, all you need is a good plan and a good strategy. Thank you.